In this video, we will introduce running the runtime RMI client example within the Java programming language. Remember that the RMI application can comprise two separate programs, a server and a client. A typical server program creates some remote objects, makes references to these objects accessible, and waits for clients to invoke methods on these objects. Let's start up our server with our run configuration. We already see here that we have it up and running. Now that we have our server up and running, behind the scenes and from the server's point of view, the following is taking place. First, the server must bind its name to the registry. The client will look up the server name in the registry to establish remote references. The stub serializing the parameters to the skeleton invoking the remote method and serializing the result back to the stub. A client invokes a remote method. The call is first forwarded to the stub. The stub is responsible for sending the remote call over to the server-side skeleton. The stub opening a socket to the remote server, marshalling the object parameters, and forwarding the data stream to the skeleton. A skeleton contains a method that receives the remote calls, unmarshals the parameters, and invokes the actual remote object implementation. That's why we're using here our interface user service, which extends remote. All of this code generation that happens in a server-side stub, as we can see here. Now you rarely need to look at any of this code which is generated for you. Now let's take a look at our client. Our client program obtains a remote reference. To one or more remote objects on a server and then invokes methods on them. RMI provides the mechanism by which the server and the client communicate and pass information back and forth. Such an application is sometimes referred to as a distributed object application. Now we'll run our client using our run configuration. If I right-click on the client, I run as Java application. Here we see the output. First, our client receiving response received hello world, which came from our server. Second, we passed in an int with the value of 2 to our find user method, which returned a user to us. In this case, it should be Lisa. And as we can see in the console, the user which was passed back to us over the wire was Lisa. The client obtains an instance of the stub class. And what happens behind the scene is that the stub class is automatically pre-generated from the target server class and implements all the methods that the server class implements. The client calls a method on the stub. The method call is actually the same method call the client would make on the server object if both objects resided in the same JVM. Internally, the stub either creates a socket connection to the skeleton on the server or reuses a pre-existing connection. It marshals all the information associated to the method call, including the name of the method and the arguments, and sends this information over the socket connection to the skeleton. The skeleton demarshals the data and makes the method call on the actual server object. It gets a return value back from the actual server object, marshals the return value, and sends it over the wire to the stub. The stub demarshals the return value and returns it to the client code. And then we're able to display it on our console. This concludes our discussion of running the remote RMI client example in Java.